Hello friends, today we start differentiation chapter. Before we study differentiation chapter, first of all, we revision class 11th. First point, derivative by method of first principle. We already learned derivative by method of first principle in class 11. So what is first principle formula? Therefore, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. By using this formula, we already find various different derivatives formulae. Then, second point, notation. Let y is equal to f of x be any function then its notation by using derivative. Therefore, suppose y is equal to f of x be any function, then how to find its derivative? dy upon dx is equal to f dash of x. This is notation is already familiar with. Then third point, note that this note is important for theorem. If y is equal to f of x is a differentiable function of x, then we can find its derivative. dy upon dx is equal to limit delta x tends to 0 delta y upon delta x. Whenever we apply delta on limit, whenever we delta apply limit, we get dy upon dx form. This notation is very important for three theorems. Here delta x is a small increment in x, delta y is a small increment in y. Then fourth point is derivatives of some standard functions. Here we are writing function form y is equal to f of x form, y is equal to f of x function. First function is k means constant, second is x, then third x raised to n. These are functions and its derivative, functions derivative. If y is equal to f of x is a notation, then its derivative y derivative dy upon dx. If f of x is given, suppose f of x is equal to k form, then how to find f of x derivative? Its notation is f dash of x. Okay, then we start first derivative. Suppose first function is k means constant, any constant its derivative is 0. Then x function, then x derivative is 1, x raised to n derivative is n x raised to n minus 1 upon x raised to n form. Then next is 1 upon x raised to n form. Its derivative is minus n upon x raised to n plus 1. Okay, remember 1 upon x raised to n, then its derivative is minus n upon x raised to n plus 1. Only x raised to n, then n x raised to n minus 1. Then fifth one, 1 upon x derivative minus 1 upon what? X square. Then sixth one function which form root x function. What is root x derivative? 1 upon 2 times root x. Then next function, seventh one, e raised to x. E raised to x derivative is e raised to x. A raised to x derivative a raised to x into log a. Then next function log x. What is log x derivative? Log x derivative is 1 upon x, then log x to the base a derivative. And what is the difference between log x and log x to the base a? Is equal to log x to the base a means log x upon log a. Here log a is constant term, therefore log a as it is. Just we have to only find log x derivative. Here log x derivative is 1 upon x is equal to, then log x to the base a, its derivative log x derivative 1 upon x. Just log a is constant, therefore log a as it is. You can write log 1 upon log a into x. Yeah, okay. This is also okay, 1 upon x into log a. Okay, both are similar. Then next functions, these are 6 functions, trigonometric functions. Okay, this is very important for next problem solving. If you don't learn this formula, then if you don't understand any problem. Okay, very important. Then first formula, sin x derivative is cos x, cos x derivative is minus sin x. Then tan x derivative is sec square x. Then cot x, what is cot x derivative? Minus cos x square x. Then sec x derivative, sec x into tan x. Then cosec x derivative, minus cosec x into cot x. Okay, before we solving problem, you have to learn all these formulae very well. Then last point, rule of differentiation. In even class we also learn rule of differentiation. There are 4 types of rule of differentiation. First one, derivative of sum of function, means we have to find some derivatives of sum of function. Which form? That is y is equal to u plus v form. Then second point, derivatives of difference of function. Difference means subtraction form. Which form? Y is equal to u minus v form. Then third form, which form? Derivative of product function. Derivative of which function? Product function, means function is given from which form? Y is equal to u dot v, u into v. Okay, this rule is very important. Lots of problem is solving by using product rule. Then fourth one, derivative of quotient function. Derivative of quotient function means which form? Y is equal to u upon v form. Which form? Y is equal to u upon v form. Here in all 4 cases, u and v are already differentiable functions. U and v are differentiable function, means we can find its derivative. How? Here we see that if y is equal to u plus v, then how to find its derivative? Y derivative dy upon dx, u derivative du upon dx plus v derivative dv by dx. Similarly, we can find here is only plus. If function contain plus, then plus. Here derivative of difference of function, y is equal to u minus v. Then how to find derivative? Y derivative dy upon dx, u derivative du upon dx, v derivative dv upon dx. Then third one is very important. If function which form? Y is equal to u into v form, then how to find its derivative? Suppose y derivative dy upon dx is equal to first function as it is, u as it is, then take second derivative. Which is second? V is second. Then dv upon dx plus v as it is, means second as it is. Here we take first function is u, second function is v. Then how to find derivative? dy upon dx is equal to first one as it is, second's derivative dy upon dx plus second as it is, then first into first derivative. What is first? First one is u. Okay, remember it's trick always. If y is equal to u into v form, then take first function and second function in mind. Then how to find its derivative? First as it is, second derivative, then second as it is, first derivative. Okay, then next rule, derivative of quotient function. Quotient function means u upon v form. If any two functions u upon v form, then we use by using derivative of quotient function formula. Y is equal to u upon v formula. Then how to find its derivative? Dy upon dx is equal to, here we starting from denominator, here is denominator v, then taking v square, v as it is, then u derivative means du upon dx minus u as it is, here u we taking u's derivative, then u as it is minus u as it is, then into v's derivative means dv upon dx. Same trick as we use in u into v formula. So v as it is, then u derivative minus u as it is, then v's derivative. In differentiation chapter, first point is derivatives of composite function. Derivatives of composite function is also called function of function, yeah, function of another function. So let us see what is meant by composite function. Its definition: if f and g are two functions, if f and g are two functions defined by, how to define, y is equal to f of u and u is equal to g of x respectively. Here y in terms of u form and u in terms of x form, that is y is equal to f of u and u is equal to g of x. Then a function new function defined by, how to define, y is equal to f of u, that is y as it is, f as it is, here is u, but we have given already u. What is u? U is equal to g of x, therefore here u we can replace by putting g of x. Now here we see that y is equal to f of g of x. So here more than one function, means first function is f, then second function is g, that is f of g of x, then y is equal to g of x. Such a function is called, what is called? It's called a composite function. It's called a composite function, yeah, or function of function, means first function is f, then second function is g, therefore it is also called function of function. Now how to identify which functions are composite function? Let us see some examples. Here I am writing some examples. First of all, which are not composite. First of all, we have to find composite function, but first we find which are not composite functions. First we see which are not composite, that is they are just looking which function, simple function. Which simple functions? Here I am taking some examples which are called simple function. First example is called sin x. Sin x is a simple function. Second function, e raised to x function. E raised to x also simple function. Third example, log x. Log x is also simple function. Why we call a simple function? Because we can find easily derivative. Sin x derivative is cos x, e raised to x derivative is e raised to x, log x derivative is 1 upon x. Therefore we call it simple function because we can find just quickly answer derivative. Okay, then how to make simple function into its composite function? Let us see. Now we want to see that how to make simple function as a composite function, or how to identify which functions are simple function, which functions are composite functions. Therefore, that's why here I am writing some simple function. Now how to make composite function. First example is simple function sin x. Then how to make its composite function. Already learned what is meant by composite function. Composite function means y is equal to f of g of x. Means first function is f. In f function, second function is g. Therefore, f of g of x. Therefore, that's why we calling its composite function. Therefore, here I am taking sin x function first, which are not composite but which are simple function. Therefore, here first function is which function? Sine. Therefore, I am writing here sine. And here is x. Here we x replace by any other function. Any other function means log x. Here taking log x function. So here which function? Sine of log of x. So this example is composite function. So here is sin x, here is sine of log x. Sin x simple function, sine of log x composite function. Then second example, e raised to x. How to make its composite? Here e writing as it is. Here just only x is replaced by any other function. Any other function. Suppose I am taking e raised to x, then here e raised to tan x, which looks like e raised to x function, but here is not x, here is tan x. Therefore, that's why we calling its e raised to tan x is a which function? Composite function. Second, third, log x. Then how to make log x composite? First of all, log as it is, then x is replaced by any other function, whatever you want, log of cosec x. Therefore, log of cosec x is a composite function because all these three functions contain two functions, at least two functions. Sine of log x, then e raised to x is not by e raised to tan x. Log of cosec x, log x is replaced by log of cosec x. Therefore, these functions are called composite functions. Okay, I think you understand very well how to identify composite function. Now here we will learn to how to find derivatives of composite function by using chain rule theorem. Okay, let us see what is meant by chain rule. So here theorem number first in differentiation chapter. This theorem is also called chain rule. So what is chain rule statement? Given if y is equal to f of u is a differentiable function of u. If y is equal to f of u is a differentiable function of u, and u is equal to g of x is a differentiable function of x, such that the composite function, how to make composite function? Here we see that y is equal to f of u form. Which form? Y is equal to f of u form. So therefore here writing only y is equal to f of not u. What is u? U means g of x. Therefore here we putting u replaced by g of x. Therefore it becomes which function? Composite function. So y is equal to f of g of x is also a differentiable function of x. Then we prove that dy upon dx is equal to dy upon du into du upon dx. Here we writing y with respect to u and u with respect to x. Why? Because we have given, what is given? First of all we see y with respect to u, dy upon du, because y in terms of u, therefore is the differentiable function of u. Then second, u with respect to x, second function is u g of x, means u which form? X form, and is a differentiable function of x. Therefore that's why dy upon du into du upon dx, actually we finding y with respect to x. Whenever we find y with respect to x, First of all, we have to differentiate y derivative. Sorry, why not? First we have to differentiate f. F function means u form. Therefore, we differentiate y with respect to u. And second function is g. G which form? U form. Therefore, u with respect to x. Therefore, if you finding these two derivative in multiplication form, we get directly y with respect to x form. Therefore, that's why first we find y with respect to u into u with respect to x. Okay, let us see how to prove this theorem. Let's prove. Let delta u and delta y be the small increments in u and y respectively, then corresponding to their small increments. Which increments? Delta x in x. Here I am writing delta u and delta y with these small increments. Increments in change. Which function changes? U changes in delta u and y changes in delta y form. Similarly, corresponding to the increment, small increments, delta x in x. Here delta x is a small increment in x. Therefore, that's why I am writing here taking three functions, u function, y function and x function. U changes in delta u, y changes in delta y, x changes in delta x. Which form? Small increments form. Okay, now let us see what is given. We have given now y is a differentiable function of u. Y is a differentiable function of u, and one more function, u is a differentiable function, but which form? X. Now in the previous lecture we said that any function differentiable means that its derivative we can find. So here y is a differentiable function of u, therefore its derivative we can find. Which form? Y with respect to u. Therefore dy upon du. Which form? In limit form. Here dy upon du, then limit delta y upon delta u as delta u tends to 0 by using definition of derivative. Since y is differentiable function of u, therefore we finding its derivative. Yeah, its derivative exists. Therefore dy upon du in limit form. Also here u is differentiable function of x. Similarly, if y is a differentiable function of u, then we also find u with respect to x derivative. Why? Because u is differentiable function of x. Therefore we can find du upon dx is equal to limit delta x tends to 0 delta u upon delta x. Okay, this concept is clear. By using this definition, which definition? Derivative definition, we can find this term, and I am giving here equation number 1. Now I am finding one more term, limit delta u. Here we want to find limit of delta u as delta x tends to 0 is equal to limit delta u as it is delta x tends to 0. Okay, here I am multiplying numerator and denominator by multiplying delta x and dividing by delta x. Why? Delta x small increment, delta x is not equal to 0. Therefore, we multiply and divide by delta x. Here, two function. Therefore, applying limit on first function, limit delta x tends to 0, first function delta u upon delta x. Now, then second function, limit delta x tends to 0, delta x. From equation first, here delta u upon delta x, limit delta x tends to 0, we get du upon dx. Why? Because u is differentiable function of x. Therefore, we can find its derivative, du upon dx, into, here is only delta x and delta x approaches to nearly 0. So here we taking 0 and du upon dx into 0, you will get answer 0. So here what we find actually, here we find as delta x tends to 0, as delta x tends to 0, what we get as delta x tends to 0, here we finding limit delta u. What we get, limit of delta u is also 0. When as delta x tends to 0, then delta u tends to also 0. Therefore, as delta x tends to 0, we get delta u tends to 0. Equation number second. Why I am finding this term? You understand in next time, as delta x tends to 0, why delta u tends to 0. Just recall equation number second, as delta x tends to 0, delta u tends to 0. Now I rearrange some terms, that is incrementary ratio delta y upon delta x. Now delta y upon delta x is equal to delta y upon into here delta x, delta y as it is, and denominator delta x, just delta x replace one side. Then what will happen here? Here multiply numerator and denominator by delta u, since delta u is a small increment and our aim is to prove dy upon dx is equal to dy upon du into du upon dx. But these are all terms which form? These are not d form. D means derivative form. Therefore, we want to change this term delta in terms which form? D form, derivative form. D form means derivative form. Therefore, here we want to apply limits on both sides. If we apply limits on both sides, then delta becomes which form? D form. D form means derivative form. Therefore, we are taking limits on both sides. Which limits? By using definition of derivative, taking limit on delta x tends to 0 on both sides. Therefore, taking limit as delta x tends to 0, we get what we get. Here is delta y upon delta x. We are applying limit. Which limit? Delta x tends to 0 is equal to limit delta x tends to 0. Here delta y upon delta u into delta u upon delta x. Here in bracket two functions are available, y with respect to u and u with respect to x. Therefore, we are applying limit on first function, limit delta x tends to 0, delta y upon delta u into second function, limit delta x tends to 0, delta u upon delta x. Okay, then next step, multiplication, limit delta x tends to 0 as it is, delta u upon delta x. Okay, here we observe that here delta u upon delta x. Delta x tends to 0. Delta u upon delta x, here is delta x, as delta x tends to 0. Now here delta y upon delta x, here is delta x, here is also delta x tends to 0. But problem is what? Here we get some problem. Here is incremental ratio is delta y with respect to delta u. But here is delta u, here is not delta u, here is delta x tends to 0. Therefore that's why we want to change here delta u tends to 0. Therefore from equation, which equation? From equation second. From equation second. What is from equation second? As delta x tends to 0, delta u tends to also 0. Therefore we replace limit delta u tends to 0, delta y upon delta u. Okay, now here we observe that delta u upon delta x, limit delta x tends to 0. Can we write du upon dx? Similarly here delta y upon delta u, limit limit of delta u tends to 0. This is also written in which form? Dy upon du. How it is possible? From equation first. What is equation first? Equation number first is if y is a differentiable function of u, therefore we can find its derivative. Which form? Dy upon du. And u is also differentiable function of x, therefore that's why we can find its derivative du with respect to dx. So here what we get? Here limit delta x tends to 0, delta y upon delta x. Here we observe that this side is LHS, this side is RHS. Which sides exists? Here is both functions are differentiable. If you multiply differentiable into differentiable, this is LHS RHS side. If RHS is differentiable, then LHS also becomes differentiable. Then therefore here I am writing both the limits on RHS exist. Exist means we can find derivative. Therefore that's why I am writing here exist. Exist and finite. Therefore implies, what implies? If RHS exists and finite, then implies LHS also exist and finite. Therefore what we get? LHS in derivative form, here is delta y upon delta x, as limit delta x tends to 0, we get dy upon dx is equal to dy upon du into du upon dx. This rule, this theorem is called chain rule. Hence proof is complete. Whenever we want to find derivatives of a function from chain rule, we use this formula. Now here I am taking one example which depends on chain rule, the derivatives of composite function. Here question is differentiate the following function with respect to x. First example, very simple example, y is equal to sine of log x. Sine of log x. Here first function is sine, second function is log x. Then how to differentiate? Then my question is how to differentiate this function by using chain rule. Our chain rule says that, what says that? Differentiate y with respect to x. First of all, you have to differentiate y with respect to u. But which function here? Y with respect to u. So that's why we putting here, put log x is equal to u. Therefore y becomes just sine u. Y is equal to sine u. What is meant by u? U means log x. Therefore, y becomes which form? In sine u form. And what is u? U is equal to log x. Which form? In x form. U is equal to log x. Therefore, we differentiate u with respect to x. If you multiply these two derivative, you will get automatically y with respect to x derivative. That's why dy upon dx. Then how to solve? Solution. Let y is equal to sine of log x. Differentiate y with respect to x. Differentiate y with respect to x. Therefore, dy upon dx is equal to, first of all, here see that first which functions see first. Here we see that first function is sine. Take log x as a u in mind. Then we here see that sine u function. If we consider in mind log x as a u function, then we see that sine u. What is sine u derivative? Just like sine x. If sine x derivative is cos x, then what is sine u derivative? Sine u derivative is cos u. Therefore, derivative of sine of log x is equal to, first function is sine. Therefore, here I am taking cos. Sine's derivative is cos. A remaining function as it is. First function will come, then first take derivative its. Then first is sine, then sine's derivative is cos. Then second as it is, log x into by using chain rule. Second function is which function? U. U means which function? Log x function. Then we have to differentiate u with respect to x. What is meant by u? U means log x. Then we have to differentiate here du upon dx. We have to du upon dx means u with respect to x derivative. We can find u with respect to x derivative. So u is equal to log x. What is log x derivative? Log x derivative is 1 upon x. We get a final answer, cos of log x upon 1 upon x into, therefore dy upon dx is equal to cos of log x upon x. Okay, you understand it? This is composition, derivatives of composite function. Let us again revise. Let y is equal to sine of log x. First of all, differentiate y with respect to x. Therefore, y derivative dy upon dx is equal to derivatives of sine of log x. Here first function is sine. Therefore, we are taking sine's derivative, cos of log x as it is. Then which functions remaining? Finding derivative log x. Therefore, multiply. We are taking log x derivative. Log x derivative is 1 upon x. Then just multiplication of these two functions, we get dy upon dx.